Okay, the next part of your video is half-life. I'm going to have to split these, I think, to upload faster. Half-life is nothing but medicine or even caffeine. I'm not sure if we discussed this at all in class, but when you drink a Red Bull, it's got a certain amount of caffeine in it, and that caffeine has a half-life. So say, for example, it's 100 milligrams of caffeine. Well, after a certain amount of time, it cuts itself in half, so it'd be 50. Maybe we'll say 2 hours, okay? We consider that cycle 1, okay? The next 2 hours, which now is at 4 hours, it would cut in half again to 25. So now we're at cycle 2. Then we would continue so on and so forth until we would finally get to the last cycle. You'll notice that these never actually touch the x-axis. They go on and on and on forever to hit 0, but they never hit 0. So there is a small trace of caffeine, and it even says it right here. Simeon is studying for a big test and is trying to stay awake. He drank a 12-ounce can of Big Buzz energy drink that contains 80 milligrams. Okay, so we're looking at 80 milligrams of caffeine. He's wondering how long the caffeine will stay in his system if the caffeine has a half-life of 5 hours. So what that means is every 5 hours, it cuts in half. But every one of those 5 hours, they attach what they call a cycle to it. So after the first 5 hours is 1 cycle. After the second 5 hours, which is now 10 hours, that's 2 cycles. After the third 5 hours, that's really 15 hours, that's 3 cycles. That's what it means by a cycle versus, the actual hours of the half-life. So it says here how much caffeine is in Simeon's body after 5 hours. Well, you would simply, that's the first cycle. So after 5 hours, it's nothing but 80 times 1/2, which is 40. Okay, it's really 80 times 1/2 to the first. It's 1 cycle. Okay, then after 10 hours, it's asking us, so now it'll split again. So what's now half of 40? That would be 20. And it would continue. 15 hours would be 10. 20 hours would be 5, which is actually now set up right here in the table. Okay, we've got our initial amount of 80. Then it splits to 40 after 5 hours, 20 after 10, 10 after 15, 5 after 20. And this is obviously our initial cycle, so after the first 5 hours, we now have 1 cycle. After 10 hours, we now have 2 cycles. After 15 hours, we have 3 cycles. After 20 hours, we have 4 cycles. Oops, not 40. Okay? So that's what it means. Every certain amount of hours is considered like 1 cycle. And that's where this number of half-life cycles comes from. Don't let that throw you. So it asks, what's the initial amount of caffeine in Simeon's body? Well, the initial is obviously 80 milligrams. And then it wants the rate of decay. Well, in this case, the common ratio is 1/2. So the rate of decay is going to be 1/2 every 5 hours. Okay? Using technology, what's going to happen? Will it ever be out of his system? Does this make sense? Explain your reasoning. Well, it will never be out. Hope you like my background music. I forgot to turn down the TV. Okay, there will always be some sort of trace. That means your x-axis, which we know is the equation y equals 0, is really an asymptote. Okay, so what that means is it will, so the caffeine will never hit 0. Okay? And if we have to approximate this in terms of how much caffeine to go less than 1 milligram, well, here's the hard part. Think of what the formula is going to be. Okay, we've got our y equals AB to the x. Well, the A is easy. It's the y-intercept, 80. And the B is the rate. Here's the tough part. When you're doing the exponent, the time, you actually have to write it in terms of the cycle. So in other words, it's going to be the time of the cycle every 5 hours. So it's actually T over 5. If it was every 10 hours, it'd be T over 10. If it was every 8 hours, it'd be T over 8. Okay, so it just depends on what the problem is asking. It's really not hard to do, but it's a little bit of a switch up on the exponent, so be careful with that. Now simply put this into your calculator, go to your table, and you will go down on the table and you see that it is less than 1 milligram after 31 hours. And if you keep going down on your table, you'll notice it never ever hits 0. So that is half-life. Stay tuned for the next part.